We have thus discussed the equation of the plane in the first two types, namely the equation of the plane in parametric form, the equation of a plane in dot product form. In this video, I hope to put together the first two forms together so you can see it better, and later on to introduce to you the third form. Okay, let's do a quick recap. For the first form, we have so-called a first vector which represents a point on the plane. Like in this case, if this is a point on the plane, which means it sits on the plane, the origin is potentially here, so this is a position vector of the point A. And then there are two other vectors which are parallel to this plane. So in the first form, we have the first vector which represents the position vector of a point on the plane, and two other vectors which are parallel to the plane. These two vectors we have also learned before that they cannot be parallel. In the second form, the argument started off with establishing a vector n which is perpendicular to the plane. Geometrically, it will look like this. So this is a plane. We want a vector n that is perpendicular to the plane. So to find a vector that is perpendicular to a plane, typically we will take the cross product of these two vectors. These two vectors, because they are parallel to the plane, the cross product of these two vectors, like in this case, it results in a vector which is perpendicular to the plane. And in this form of the equation of the plane, you now know how to find this vector n. To find this numeral, this is a number. To find this number p, what we will do is we will take a point on the plane to dot product with whatever normal vector n you get for the plane, and you just perform the dot product, you get a numeral. Putting this numeral and the normal vector together in this equation, we have actually what is called the equation of the plane in the dot product form. You want to notice that in this case, I can potentially change this equation by dividing both sides by -3 to arrive in a more simplified version of r dot 1, 2, 3 equals to -26. So you can either give an answer in this manner or in a more reduced form. Both are just as good, but typically people who want to reduce it into a simpler form, like the green color. And moving on from the first two forms of the equation of plane, you now want to move on to the third form, which is called the Cartesian equation of plane. And I want you to know that the third form is, I would say, the easiest. All you needed to do is to replace this vector r as x, y, z, and then just perform the dot product, you get this equation, or in this case, if you dot product these two, you get this equation. This equation or this equation is known or is deemed the Cartesian equation of the same plane pi 1.